Today, let's talk about the AVEVA Edge Data Store. Now, the Edge Data Store is a lightweight data collection and storage application that's designed to capture data at the edge with industrial data connectivity for historical storage and analysis. It runs on small, lightweight, rugged devices, or can be embedded in existing industrial hardware, and it's designed to be resilient and require minimal installation and administration. It's not a replacement for a Pi system or Connect Data services, but it augments those by collecting the data and storing it in situations maybe when deploying a full system is not quite practical. We want to talk today about its capabilities, what components are within it, and how you can actually use it at your own sites. Now, what's inside the Edge Data Store? Well, first, it's able to collect data using a couple different methods. It has built-in Modbus TCP and OPC UA connectivity, so you can just directly connect to Modbus TCP or OPC UA devices. It can also accept data that's written to it via the open message format or just via the native Edge Data Store REST API. So if folks have custom data sources where they want to generate their own REST data posts and have those be stored at the Edge Data Store, you can absolutely do that as well. And once that data is collected here, the data is actually stored locally in configurable data storage until it can be sent to more permanent storage in a Pi system or Connect Data services via periodic egress. And yes, that transmission is indeed buffered, it's encrypted from the Edge Data Store up to its destination. And the exciting thing about the Edge Data Store that makes it different from something like an interface or an adapter or connector in that in addition to collecting data and egressing it and buffering it and encrypting it, it actually does that storage, which allows that data to be accessed via the Edge Data Store REST API so that say like a custom application or other component that wants to do data analytics out of the edge can actually access this data and retrieve it. I'm going to talk a little bit more about like what's inside the Edge Data Store and how it can actually work, because there's some interesting differences between this and say traditional components as well. So the Edge Data Store is supported on a wider variety of platforms and processors. We have installation kits available for these for Linux Debian 10 and 11. They can be supported on Ubuntu 20.0.4, 22.04 for Windows 10 Enterprise, 10 IoT Enterprise, Windows 11, and can even be installed and run within Docker containers. Now, even in terms of supported processors, again, here's something that's very different. We're not just talking support for Windows, traditional Intel x86. We also support ARM processors. And here we're talking support for things like single board computers that can fully run a native Edge Data Store. Altogether, the main piece of this gives you wildly greater flexibility for where you want to install your Edge data collection, egress, and storage. And we even provide like tar.gz files with binaries. You can build your own custom installers for Linux or within your own containers. And our documentation goes through how you can create, for instance, like Docker configuration files for running this in your own containers that you can expand on. So yes, some great capabilities within the Edge Data Store for letting you tailor more flexible software deployments. Now, yes, Edge Data Store does include by default the ability to collect data from Modbus TCP and OPC UA sources. However, it's absolutely also compatible with other AVEVA adapters. So if you want to use the Edge Data Store to also collect data, say from a backnet device or from a SQL server or from an MQTT broker, you can absolutely do that as well. So yes, while it includes Modbus TCP and OPC UA, you can absolutely expand on this to also gather other industrial data sources as well. Now, let's talk a little bit about what is inside the Edge Data Store and some other considerations for it. Now, the Edge Data Store is designed to work in a first in, first out method. So as new data, let me go ahead and erase the ink here. As new data enters this storage, as the size of the configured data messages exceed the configured limits, older data is purged. So it operates as a ring buffer. It's not just going to continuously eat up every single bit of space on a machine until the host operating system is no longer able to function. It will actually run in a continuous cycle, erasing older data when new data events come in. So it's able to keep itself running evergreen all on its own, erasing older data once its storage limits are exceeded and egressing that to make sure that the continuous streams do always end up in Connect Data services or in your Pi server. Now, just to talk a little bit more about what this egress rate can look like. Again, the Edge Data Store is designed to support Edge software deployments, and we have a couple configuration tiers that we can recommend. Altogether, for a device, say, where this whole platform is running on something like one core with 0.5 gigabytes of RAM, here we're expecting performance that can accept about 200 data streams through the Edge Data Store with rates at about 30 events per second. As we grow higher, say to like a dual core machine with 1 gig of RAM, here we're talking like 300 events per second and about 2,000 streams. And as we get larger and larger and provision things like 4 cores, 4 gigabytes of RAM, there we can expect things. We're using something like SSD storage on the order of about 3,000 events per second and 3,000 streams here in this storage. So again, altogether, the idea here is not to replace something like an AVEVA Pi server, but to provide options where installing something like a Pi server is not actually practical. Now, let's take another step to erase all this, and let's talk about the security layer that surrounds the Edge Data Store. Now, the Edge Data Store allows itself to be configured via a REST API. You can retrieve data via the REST API. You can write data via the REST API. Now, that REST API is only accessible via localhost, which means any code that needs to read or write from this Edge Data Store needs to reside on the same device where the Edge Data Store is running. And thus, as security best practice, it's only administrators who should actually have access to the device where the Edge Data Store is installed. Now, by default, that REST API listens on port 5590. This is absolutely configurable as well. You'll actually see me using this port later when we open up a demonstration and actually get into this. Now, in terms of getting into a little bit more details on how we actually handle security of the data when it's being stored, when you are egressing data, yes, you have to be able to write to a Pi server, have to write to connect data services, and you have to be able to use things like passing along credentials, client IDs and client secrets, and things like the username and password for writing to the Pi server's web API endpoint. It's very important to mention that yes, the sensitive information that's inside the Edge Data Store, such as passwords and client secrets, yes, those are saved in encrypted configuration files, and it's only the Edge Data Store runtime that can actually store and retrieve those protected data items. So you cannot even manually even edit those. If you do, you'll absolutely cause failures of the Edge Data Store. Additionally, in terms of the service account that this entire application runs at, the installer creates a specific user account that this Edge Data Store service runs under. The account's absolutely only used for running the service. It can't be used for things like interactive sessions. It cannot even be, it's not recommended that you configure this service account or modify it. Again, could cause undesirable operation of the Edge Data Store. So those binaries, configuration files, all the data files, the installer can configure those so that they're only allowed appropriate access by the service account. It's not recommended you modify the permission or like ownership assignments for any of those. So yes, we are securing the data in transit. We're allowing you to securely store those credentials, and we're configuring it so that it's actually installed with least privileges access using its own service account that reduces the chance of that account or those permissions being abused in any way. Now, let's go ahead and talk about this in a little bit more detail in terms of what goes on inside the Edge Data Store. It can be configured through the Edge command utility to allow it to connect to, say, a Modbus TCP device, to connect to an OPC UA server, through the Edge command line utility, or through any tool that's able to make REST calls, such as curl, for instance, which you'll see in our example. Our documentation walks through examples of how you can, say, configure Modbus TCP or OPC UA data collection. Now, I'm going to show you through the documentation quick highlights of what that can look like. Then we'll actually open up an Edge Data Store and show you a bit of an interactive walkthrough. So let's go ahead and look at where you can find this in the documentation. Go to Edge Data Store. Under the configuration section, you can see mention of the configuration tools that are possible, things like the Edge command utility and REST tools like curl for passing configuration via REST messages. And let's talk about how you can configure the Edge Data Store to actually gather data. Now, OPC UA and Modbus TCP function roughly similarly, so I'll cover these in highlights. So first, whether you're connecting to an OPC UA source or whether you're connecting to a Modbus TCP source, the first piece is informing the Edge Data Store of how to collect data, where to connect to its data source. So for instance, you can say, let's pick OPC UA. I can say you have to use curl or the edge command utility to upload the configuration of where your OPC UA server resides. For instance, what's the endpoint URL for accessing data via OPC UA. And there's various configuration parameters. You can configure whether you want to use a secure connection. If this requires a username and password, you can provide those along. You use curl or edge command to basically upload this configuration to the Edge Data Store. It then stores it securely internally. It encrypts any secrets or sensitive information that you're including in this. So you use edge command or curl to inform the Edge Data Store of what's your data source, where is it. Say for a Modbus device, this is informing it of what's the Modbus port number and what's the IP address, for instance, where your Modbus device resides. After this, you're also able to configure which specific data items you want to gather. And this is under the step called data selection. Now, both with Modbus and OPC Array, you're able to inform the Edge Data Store that you want to select specific pieces of data from the source. Say, for instance, for an OPC Array server, you can say, okay, I want to follow this path for this specific node ID. I want to gather a stream called cold side inlet temperature, and I also want to gather my outlet temperature. And so you're essentially specifying your OPC UA node IDs. You're perhaps giving it a custom name. And the Edge Data Store from that point is able to use the data source configuration to first connect to the source, then follow this data source configuration to actually pick specific data items. Now, OPC UA is an interesting protocol in that it supports data source discovery. This will get discussed in other videos, but the idea of not having to specifically mention which data items you want to select and allowing the adapter to do discovery, interrogate the source, and actually find items that are available. And it can drastically speed up your selection. There's much more configuration options that can be done here about how you configure your client connection, any data filtering. But again, the general steps for configuring an Edge Data Store to gather data are first, configuring the data source, what's the IP address or what's the OPC UA URL, for instance, then selecting under the data selection configuration which data items, or for Modbus, this would be what registers you wish to gather. And then finally, you can configure how you want this data to be egressed. So under the data egress piece, here is where documentation walks you through how you can configure the Edge Data Store to write to something like a Pi server or to connect data services. There are examples included for how you would configure those JSON messages to inform the Edge Data Store where to send its data. So you can say that you want to send it to connect data services, for instance. You provide your client ID, client secret. You can say you want to actually send this to a local Pi server through the Pi server's web API endpoint, because it's going to send data to the web API via OMF. So you would inform it, okay, where's your web API installed? What's the endpoint? And what's the username and password that you would use to write to it? You can even provide other configuration parameters, such as whether you want to validate the endpoint certificate or do other configurations or filters here as well. So under the periodic data egress section, that's how you tell the Edge Data Store, okay, not only have I connected to a data source and selected specific data to gather, but now I'm telling you how to egress data and where. Finally, Edge Data Store also supports sending health information about its internal operation. This can be very useful for allowing you to monitor the deployments of these Edge Data Stores, or whether you're using a Pi server or Connect Data Services. So after connecting to your data source, selecting data, and setting up egress, you can also configure health information to be egressed as well. This will send this along, again, to an AVEVA Pi server through its web API endpoint, or you can send this to Connect Data Services. Altogether, just in brief summary, this configuration can be done either via REST tools like curl or via the provided Edge command utility, which allows you to do command line uploads of that configuration. And what I want to do next is actually show you a little bit of like what those configuration commands look like. So I can open a command prompt really quick. And here you can see I've opened Windows command prompt. I've used SSH to connect to an Edge Data Store that's running on a host called Linux SBC1. And this is important because, of course, I'm demonstrating the fact that the Edge Data Store is running on a Linux platform, not actually running on Windows. And you notice that I've used SSH. And that's important because now any commands that I issue to the Edge Data Store are running locally. Again, remember that REST API, all configuration and access to the Edge Data Store through the REST API, that has to be performed from local applications. Yes, the Edge Data Store can absolutely use Modbus and OPC UA to reach out to separate physical Modbus TCP or OPC UA data sources. But if you are using the REST API to write data or read it out, that has to be done locally from the same host. And that's why I've created an SSH session. So now all my commands can be run locally. And sure enough, I'll use that edge command line utility, and I'll say edge command get version. And you see, this is going to give me Edge Data Store. It's going to show me what its version number is. So it's confirming, yes, Edge Data Store is is installed right here. And I'll also say edge command get application. You can see what it's going to do here is it's going to return the current configuration of this Edge Data Store. You can see right off the bat, I can see that egress endpoint configuration as well. You can say I'm egressing data to my local AVEVA Pi server. I've got my username, I've got my password, I've got my endpoints, my IP address. You can see the password is not actually retrieved. It's stored in encrypted internal storage, so it's not actually showing that to me in plain text. It's trying to protect me there. And down below, of course, is other things like health configuration and configuration for connecting to OPC UA or Modbus sources. Now, to show that the Edge Data Store also can store data and that I can retrieve it, let me go to a different tab. Let me scroll up and show you a different command. Here, I'm not using edge command, I'm using curl. And so I'm issuing a web request, a get request to the Edge Data Store's REST API. I'm saying curl get to the local host where the Edge Data Store is installed. I'm using that default port of 5590. And I'm going to default tenant, default namespace, and I'm saying show me all of your streams, and use JQ, which is a separate Linux utility, to print them in this friendly JSON format. So I've issued this REST request to the Edge Data Store, and now you can see, yes, this is actually going to the Edge Data Store's internal storage layer and showing me what data streams it has inside it. You can see it's got some single value types, it's got some X acceleration, Y, Z, it's even got a complex type. So yes, the Edge Data Store, like Connect Data Services, can store complex data as well. It does not just have to store data from adapters or single timestamp value data streams. It's very important to note that the Edge Data Store can indeed absolutely support complex data. And so in addition to, of course, storing this data and egressing it, one of the goals, of course, is for it to allow applications to use the Edge Data Store as local storage so that they can retrieve data and write to it, which means I can also use curl, talk to 5590, tenant's default, namespace is default. I can pick one of these streams, such as my 1041 accelerometer 1 stream, which happens to be a complex stream. Let me see, you see this stream right here. I can say, get me the stream, get me a stream with this ID /data/last. And so now it is actually giving me the most recent value from the Edge Data Store. And if I arrow up and rerun this command, you can see now I've got slightly different data. You see my X acceleration is still about 0.993, but now it's 0.99313. My Y acceleration is negative 0.10813 Gs, and Z about 0.0124. So the Edge Data Store is not just collecting this data, but it's continuously archiving all of these new values in addition to storing them locally, egressing them. So if I wanted to create a local application that's, say, a visualization or a machine learning program that's going to do some intelligent analysis of my data and contribute some new streams, some new findings, and then send those along, I could absolutely use the Edge Data Store as my local edge data storage and have my application query it and use it for its source, for its analysis and visualizations. And on the AVEVA GitHub site, we absolutely have examples that can help accelerate this. Within the AVEVA GitHub repository under AVEVA Samples OMF, we have sample code for how you can write to the Edge Data Store and actually write OMF messages to it. So if you have an application that's going to perform some data access from the Edge Data Store and write values to it, you can use the open message format to write those values in a very streamlined and straightforward way. We can provide examples for how you can do that. Similarly, under the Edge Data Store's documentation, under the SDS API reference, you can read on how you can actually read data out of the Edge Data Store. For instance, when I issued that read request to get a single stream and actually read data from it, you can learn about how you can retrieve data either from a single stream or from multiple streams to allow your Edge application to build the data sets from the Edge Data Store's data and use those in its analytics. Again, just to reiterate that here, I can arrow up one more time in my command prompt, say, okay, Edge Data Store, give me the most recent value for this stream, go. And sure enough, you were seeing some slight drift or some slight vibration perhaps in this accelerometer. I can use the Edge Data Store not just to collect data and to send it along, but because it has this internal storage layer, I can use this REST API to retrieve data. I can also write data back into it. So again, the intended result of the Edge Data Store, not necessarily to replace something like an AVEVA Pi server, to provide instead local data collection and egress and local storage to empower additional applications that want to use the Edge Data Store as that valuable source of data for analytics, for visualization, and to be able to write values back into it that will then be egressed downstream. Finally, it's worth noting that, again, as the Edge Data Store is designed to be supported on edge deployments or in streamlined installation, it is very easy and straightforward to install. The single install kit, whether you're running on Linux or whether in Windows, allows you simply to change the installation path, which we do recommend you leave it as the default, to specify which port number should be used for the REST API so that it can access and retrieve data, and also whether you wish to enable a Modbus and or OPC UA data collection. You can either leave those on, or you can actually leave them off if you mean to use other adapters along with the Edge Data Store. So a very streamlined installation process, whether you're running on Windows or whether you're running in Linux or whether you're doing something like configure it in Docker. So altogether, again, idea of the Edge Data Store is to provide that lightweight local storage in addition to secure data collection and egress. We're providing our users the ability to collect data from industrial sources, to do so with software that's designed to tolerate network interruptions, and with its brand new architecture design to support things like intermittent power failures or ungraceful restarts or variable speed networks, to do so in a light footprint installation that can accept and can tolerate things like 3,000 events per second, but can also run on single board computers powered by ARM chipsets. And again, unlike something like an adapter or connector or an interface, in addition to connectivity, in addition to being robust and resilient and allowing installation on light footprint locations like an adapter, Edge Data Store provides that edge storage, egress, and access for other applications that wish to take advantage of that data for edge analytics or visualization. Of course, if you have more questions about the Edge Data Store, absolutely recommend taking a look at the documentation. There's some terrific examples here. The online GitHub repository has examples on how you can use the sequential data store API, or how you can use the open message format to read and write data in now the Edge Data Store. And of course, you can reach out to us if you have any questions as well. Looking forward to hearing about your use cases and how you can put the Edge Data Store to work for you. Thank you.